Hello everyone, welcome to Advantech webcast. Recently, industrial HMI has undergone significant technological developments. Widescreen and multi-touch innovations will not only change the face of traditional HMIs, but also enable HMIs to be used in an increasingly diverse range of markets. Through this webcast, you'll learn about the benefits and possible issues of the next generation HMIs, emerging opportunities, and how they'll affect different parts of the industry. To help us understand more about the new developments and learn about how they are changing the face of industrial HMI, we have invited Johnny Chang, Director of the Industrial Automation Group for Advantech. He is mainly responsible for the human-machine interface sector of Advantech Industrial Automation Group, including the business sections of operator panels, control panels, thin client panels, and industrial monitors. Hi, Johnny. How should we be looking at changing the face of industrial HMIs? And why do you say that it's changing?
As we know, HMI are the only point of interaction with automation systems, such as wind turbine phones, large refinery, vehicle manufacturing plants, or other industrial applications. Today, the method of the controlling these devices has moved toward touch screen and away from the mouse control. In industrial applications, the most commonly used technology today is analog resistive single-point touchscreen technology. This technology is mature, it's very reliable in the most traditional industrial environments. In addition, display for control applications are undergoing some significant changes, which are being driven by trend in the wider PC industry. This transformation involves both the additional of the wider aspect ratio and the multi-touch capabilities. The first is well underway, while the second is just beginning. In the PC industry, the switch from a square 4:3 aspect ratio is the widescreen 60:9 or 60:10 aspect ratio is nearly completed. This means that most developers and users of the industrial computer in the office, except for legacy system and installations, are in a 60:9 or 60:10 aspect format. For a while now, multi-touch technology has been available for smartphones and mobile computing aids, and that's changed user behavior, whilst allowing the more efficient capturing of the information. As its name implies, multi-touch recognizes multiple simultaneously touches. Windows 7 is the first operating system to support multi-point detection and gesture recognition. For example, the stretching and the rotating of the object with two fingers compared to the commercial mobile devices. Multi-touch concepts in industrial application are still in their infancy.
Why do you feel that multi-touch HMIs will take off in the industrial sector?
Well, smart mobile devices in the consumer market have already paved the way for the multi-touch HMI in the industrial. Projected capacitive touchscreen and Windows 7 provide a solid base to realize individual operator concepts. The flexibility in choosing several hardware formats, such as the standard 4:3 screen size, or by using the 60:9 widescreen format, will help machine and equipment builders find new solutions. For example, the portrait and the landscape mounting capability of the widescreen HMI hardware providers new space-saving solution for improved usability in a factory environment. Already, most of the SCADA and HMI software suppliers have implemented gesture capabilities and multi-touch screen features in the operator interface. From 2012, all major automation suppliers in industrial offer various multi-touch and widescreen HMI solutions from 10 to 24 screen sizes. A typical scenario is to set the parameters of different devices. The operator selects an object with one hand and change the value of the selected object with the other. The combination of the using both hands improves the machine's usability and ensures mistake isn't made. Another example is the position of the exit drive in CNC machines, which may require two-hands operation for safety reasons. A further example is information around the machine's serviceability and quality control applications.
What are the benefits and possible issues of widescreen multi-touch HMI?
If implemented correctly, widescreen HMI can boost the productivity. This idea is supported by a 2008 study. This study found for end users an upgrade of the world system from an 18-inch 4:3 ratio screen to the 24-inch widescreen setup cut the average time. It took to complete the task by 52% in case of the text item and 29% for the work with the spreadsheet. It can be argued that the increase in productivity is solely due to the increase in the number of the pixels. However, the same study compared dual 20-inch 4:3 aspect ratio monitors with a single 24-inch widescreen display. This showed the latter was about 10% more productive for test tasks and slightly more productive for spreadsheet. As a result, this research revealed that the widescreen format itself increased user productivity. It's not just end users that benefit from the widescreen. Developer too will be able to take the advantage of the greater productivities. For example, if developers use a 60:9 aspect during development, they will be able to reduce it to the 4:3 ratio for testing purpose without having to switch machines. Furthermore, there are some benefits to multi-touch panels, driving the general adoption of them. Multi-touch will be both familiar and widespread. Soon, everyone will know how it works. Everyone will expect to be able to touch the screen and make things happen. So, with the multi-touch capable HMI, operators will see something they understand, resulting in the need for this training. After all, end users have to spend years working with the multi-touch smartphones, tablets, and the computers. But they bring up an important point. That's only the plus if the interface isn't what's expected. If spreading two fingers run out instead of in, for example, all that past experience and practice will actually be a disadvantage, not a benefit. So, industrial HMI manufacturers need to mimic what users are seeing on the consumer side for the basic multi-touch functionality to see this benefit. Another reason to go multi-touch in a HMI is simplicity. Operators need the screen to see the system information. There also has to be a way to select the items, input information, and enter comments. Putting all these functions into the same display cut down on the needs for the multiple components. Fewer components can reduce the change of value. Sometimes industrial environments where HMI are installed can be all of the loads over a day or a year, so the screen has to take that abuse and still work. It has to function as the display and have the capability to handle touch, perhaps for a year. It must last for the design lifetime of the system. For multi-touch screen used in an HMI, failure is not an option. Check the wind turbine. It can be shown on the screen, run in at the location, and you get the details about the particular part of it. That could be, for instance, the gearbox run out and you get back to the overall picture. Swiping can bring other information into view. For example, it could be a log of the data. Say that you wanted to see how much electricity the wind turbine has been producing over the last few hours. A swipe can bring that up and another swipe could be put in the way. The panning and the rotating are other possible operations. Gesturing, say by drawing circles around particular picture elements, can be used to log in instead of the type possible. Typing can still be done. Just call up keyboard on the screen and tap away. Taking advantage of these increased capabilities requires some planning in hardware and software. Because widescreen HMI has more pixels, roughly 43% more than 4x3 displays. The processor and graphic chips have to do nearly half as much work again. The addition of multi-touch also means that the pixels have to be redrawn on the fly, resulting in the further demand on the system. The use of the dual-core processors and the greater is helping to make this much smoother. If, however, there is not enough power in the configuration, any benefit arising from the multi-touch and the gesture control will be redundant. The use of multi-touch widescreen HMI could mean that the redesign of the entire user face is needed. If the object on the screen can easily be run into or out of, it might take sense to reconsider where objects are placed, how they are depicted, and what is revealed as the result of the running in. The same is true when objects can be rotated. Should they now be in 3D? How should it be accessed? What configuration will be the easiest to use and present the most information? It's the complicated process that the company will need to analyze. The payback of doing this work is that such modifications may make the user interface both more powerful and simpler to the master. In summary, the driving factors behind widescreen multi-touch HMI are better usability to reduce the production costs, higher machine throughput, and the better user efficiency, including safety features. There are, however, some possible issues to deal with.
How will widescreen multi-touch panels impact HMI platform providers, system integrators, and end users?
For HMI providers, multi-touch input is an opportunity and a challenge. On one hand, they can rethink their product and make it better. Check the process control system. Without multi-touch input may only be through the keyboard and a simple graphic interface, such as scheme works, but it can be cumbersome. Say you want to get the temperature data at the given process point. That may take many steps. First, you have to select the point of the interest. Then you have to click to reveal or pull down the menu on that. You then select the parameter of the interest. In this case, the temperature. Finally, you scroll through the data until you find what you want. In contrast, multi-touch could make things easily. 2 fingers or perhaps hands. Make it a snap to select the point and run in on it. The important process data for that the point can be on a screen that sits just outside of view. A swipe brings it up, then dragging a finger up or down can send the data scrolling by. There's no keyboard involved, no drop-down menu, no moving a pointer up the top of the screen or over the sides. Everything's done at the point of interest. That's the opportunity to have the system that allows users to be more productive. On the other hand, that's also the challenge. Redesigning an interface so that it works better is not easy. It takes some carefully through. How do people really use the system? What do they care about? What is the lesser importance or perhaps the totally unimportant? There has to be a thorough analysis on how to best answer those questions. There also has to be some serious thought about how to best make use of the multi-touch. For system integrators, multi-touch offers some good prospects and the possible pitfalls. The prospect comes from helping customers solve the problem. They may want to boost productivity or make chaining easily, or where design multi-touch HMI could do that. The could is important. A system integrator knows a particular customer and a situation. That knowledge can help transform could into this. So one challenge for the system integrator lies in knowing what solutions are out there. Another is the knowing how to tailor a general solution to best fit a particular setting. Solving that puzzle is what system integrators do as part of their job. Multi-touch just means they will need to know more, both about the technology and the customers. As for end users, the impact of the multi-touch could be profound. After all, what's the display and how you interest with is the HMI, at least the part that the people care about. Think about phones for a minute. Recall what it was like work with 1 year ago. Now compare that to what you do with one today. Part of the change is the phone are much more powerful now than they were then. Another difference is that the bandwidth is much greater. But some of the improvements is due to multi-touch. You can easily do things now that would have been very difficult to do before.
What are the consideration factors for designing HMI solutions?
Okay, there are 4 factors to consider when designing the right HMI solutions. First, there is the application itself. Industrial automation HMI control a machine or process. As all of the important parameters for a given situation should be factored into the design of the control system. This can include the temperature, the pressure, the flow, the speed, and a number of the other items. The exact markup of the list will depend on the application. The HMI also has to manage the process output. A wind turbine farm, for instance, may be producing electricity for a grid. The amount will be adjusted based upon the demand. The electrical output will be raised up and lower as needed to satisfy the grid. It's this type of application-specific item that must be considered first when designing the right HMI solution. Second, operator experience is important. They will come to the task with certain expectations. So, rotating the view of an object by the grabbing an edge may need to be included, much like a run in or out by moving fingers. There are multi-touch standards today. but the technology and application of it are changing repeatedly. Now, standards in how things operate are likely to rise, so you need to pay attention to what is going on in a wider computing world, but you also have to take care in duplicating in an HMI.
What HMI solutions will be available in the future?
Sure. Clearly, multi-touch will be part of the standard toolkit. Touch and the ability to interact with the system using fingers and hands is just too basic for the people not to want and use it. Another likely scenario is the more powerful HMI. Most rows are still going strong. That means computing is getting cheaper every year, so it's possible to draw more the transistors at the problem. The hardware that run HMI will benefit from this. Therefore, HMI will be able to do more and more. That also leads to another HMI prediction. Look for bigger screen or more screen real estate in terms of the pixels in the X and Y axis. A more powerful HMI will be better able to handle the higher resolutions. HMI will continue to be more and more connected. Networking both to the office and the plant flow will grow. It's also get easier to connect, but HMI control vital infrastructure and the plant machinery. That requires the last system be tightly secured, even as they are connected. Speaking of the networking and the more powerful software, future HMI will increasingly be mobile and connected. The incorporation of multi-touch into HMI will make this easier. In all of this, there is the one thing to keep in mind. Machines are changing, people are not.
We know Advantech has a new series of widescreen multi-touch HMIs hitting the market. Could you take a few minutes to introduce these new products to us?
As you mentioned, Advantech has recently released a series of the widescreen multi-touch industrial HMI into the market. I truly believe that the products will not only change the face of the traditional HMI, but also enable HMI to be used in an increasingly diverse range of the application. Firstly, let's look at the hardware design. This new design is the winner of an EVE Product Design Award, and it used magnesium alloy to reduce its weight by 35% compared to aluminum alloy. It's IP65 certified and has multi-colors LED as well as customizable light touch keys. In our product portfolio, we have unique and identical design for 3 applications and segmentations. Our product offering are TPC touch panel computer, SPC stationary panel computer, and FPM flat panel monitor. All of these products support various display sizes, including 15.6 inch, 18.6 inch, and 21.5 inch. In addition, this new HMI features dual-core processors for powerful computing and an independent graphic accelerator to improve graphic performance. Additional feature highlights include multi-touch with projected capacitive touch and multimedia I/O such as HDMI and audio, which are innovative functions being driven by the consumer market. Furthermore, Advantech's new widescreen multi-touch HMI features a software utility for customized, intuitive, intelligent keys in front of the bezel. Next, let's look at some application-oriented designs. Firstly, in panel mounting for machinery, The Advantech TPC excels because it uses a fanless design with heatsink to enhance reliability and increase usability. This product series features rich I/O, which can fulfill different customer requirements, and the downward design helps to reduce installation space. Furthermore, our storage device design gives customers easy access and maintenance. Secondly, in a stationary market, standalone panel computers are fully integrated with rugged and all-around die-cast IP65 certified design with M12 waterproof connectors. These features allow for more easier clean in the production process. In addition, this series comes with the 100 by 100 mm VESA design, so it can be easily installed by arm or stand, especially in automotive and the semiconductor industries. In order to fulfill some customer requirements in the machinery market, who have their own controllers or limit space for equipment, Advantech has our FPM series. This customer usually use Advantech's FPM products, which feature a separate controller to save installation space and keep the product consistent. Based on the customer profile, Advantech's FPM series is slim, compact, easy to install by the panel, VESA, arm or stand mounting. Earlier in this webcast, we mentioned the impact on the HMI providers and discussed how do people really use the system and what do they care about. Those factors are the key driving force leading Advantech to design out the new HMI product family based on our users' scenarios. Traditional HMI usually require at least 2 people to install the system, but now Advantech has designed our new HMI with special snaps that simply lock into place by the installers. As the result, one person can now easily install the system, saving on the labor and installation cost. Another design consideration was how to increase the value of the system integrators. We understand that they know particular customer or situations. Therefore, in our design, we provide a software utility with 2 intelligent keys in front of the bezel. System integrator can easily create their own software functions by customized source code for different specifications or applications. As the result, either the system integrator can use Advantech's intelligent utility, or the system integrator they customize the virtual keypad in an extra area of the widescreen. This feature makes the whole system more intelligent and easy to manage. System self-diagnosis and management is becoming more and more important in the total solution. Manufacturers put a lot of effort on ways to reduce the system downtime caused by the sudden system shutdown. Advantech is no exception. We have developed a system that uses integrated intelligent EC chip technology that makes the devices more intelligent and allows users to remotely monitor them, switch them on and off remotely, initial system recover and system protection. Now, I would like to take a few minutes to show you how Advantech's multi-touch widescreen HMI can be used in different industries. Firstly, in the food and beverage industry, the operator usually washes the machine to clean some dirty elements. But think about it, if the touch is still working, then how you disable the touch function? This is great application to illustrate the importance of the designing the intelligent keys in front of the bezel. With Advantech's innovative panel design, the operator can simply disable the touch function by long pressing the H key on the front of the bezel. No matter where you touch on the screen, the touch function will not work and a message will be displayed to indicate that you need to long press the H key again to enable the touch function. Secondly, in automotive engine process applications, most end users want to manage the whole process by SCADA software by simultaneously knowing what the status is for each panel located at the AV station. As the result, they need to switch back and forth between two different software packages. Advantech's new HMI offering makes this easy. I will quickly demonstrate how to switch between the SCADA software and Advantech's SUSI software for remote management. To do this, you simply need to press the I key on the front of the bezel to initiate a utility designed by the Advantech called SUSI. This utility includes setting, system management, and a quick start function. We can customize SUSI in quick start and access it from this I key to do the software switch. The H key will get you back to your SCADA software. It's that simple.
How do these systems fit into the big picture?
The system integration and the seamless integration are the key to the success of our customer projects. In order to achieve this goal, Advantech is not only actively involved in the integration of the variety of the hardware interface, consistent protocols, fully designed SCADA HMI systems, from the tool library to the automation software. But we are also making all of them seamlessly integrated for both hardware and software. The software is the key for us to penetrate any vertical industrials. WebOP Designer takes care of the information under the control level. Advantech's WebOP Designer passes information to the web access for the central and the database management. Through web access, information can work with MES, ERP system, and third-party apps. This information can also be managed on the cloud. With Web Access Plus program, we can penetrate the variety of the vertical markets. In plant level of manufacturing, owing to the trend of the cloud computing with mature community trends, everybody can share their information right away in the cloud. Of course, they can also get the timely information from the cloud as well. We can combine the application with the IT infrastructure to provide specific applications to increase the production productivity. Advantech offers a cloud tool called Cloud Builder to help the system integrator build a private cloud which belong to their facility, plus they install the SUSI platform of the apps. You can access manufacturing apps from your cloud and download the production apps to run in a production. For instance, shop floor control system apps. In addition, system integrators can write some apps which belong to their own company. With plant level and machine level integration, it can increase productivity and create more efficiency. We integrated all of the Advantech panels and make them more intelligent with very special design to provide a suitable panel in different applications. In the machine level, we do have entry-level operator panels with WebOP Designer's HMI software, as well as high-end control panels, which are connected with third-party brand PLCs. In plan level, thin canine panel provides 4x3 or 60x9 products, which is suitable for system integrators as they can be used in various applications.
Thank you, Johnny. We did learn a lot about the widescreen multi-touch HMI from you. And thank you all for joining us today. If you have any questions regarding today's webcast, please don't hesitate to contact us.